Okay, so number 4 is asking us to find the radical function that is the inverse of y equals. Remember that when we are finding inverse functions, we need to switch up the x's and the y's. So in order to make this a little bit easier, I think we're going to be best off by multiplying these together. Okay, so when we do that, we will end up with x to the third, and we have y equals x to the third, and then we're going to have plus 3x squared, and then we have plus 9x. Now I'm ready to multiply negative 3 times all this stuff. That gives me negative 3x squared, negative 9x, and negative 27. Now let me add all of my like terms together. So that gives me y equals x cubed. Oh, do you see these go away? And you see these two go away. So that leaves me with negative 27. Cool. All right. So now we're ready to actually write the inverse of this. All right. So that gives us x equals y cubed minus 27. I'm just going to bring the 27 over here, which leaves me with x plus 27 equals y cubed. Do you see why they're saying find the radical function? Because we have to take the cube root of y cubed to get y by itself. So that's what I'm going to do right here. Take the cube root of that, take the cube root of that, and that leaves me with y equals the cube root of x plus 27. Whew, that was a long process getting A answered. So now we need to identify the domain and range. My recommendation, remember, this is all the values of x that you're allowed to use and all the values of y that you could potentially have as a result. My suggestion for this is to actually graph this on Desmos and see what the x values and what the y values are when you graph it, because it's an easy way to just visualize it rather quickly. So I'm going to pull up Desmos and enter this into the calculator. All right, so the first thing we have is y equals, and now we need to come here and get the cube root, which I believe is right here, cube root of x plus 27, I think. X plus 27. Ooh, it looks like it's going all flat on us, doesn't it? Well, no worries. Let's just adjust the measurements here a little bit. Let's just kind of zoom it in a while so we can see what's going on with this graph. You see I'm just zooming it in. Now, it's true that right here at negative, like negative 20 maybe, or negative 25, there's this point of inflection. Do you see where there's that little hiccup on the x-axis? But that does not mean that it's not still a function. So do you see it's going up very gradually on the y-axis. Over here by 200, it's just up just a smidge. But if you would keep going long enough, eventually it would be in basically all reals is the domain is all reals. Okay, because all the x values going both negative and positive directions can be included. And the range for y is also all reals. Okay? And that even though the really big y values and the really small y values, the really negative y values, won't be used for quite a while. In fact, you would have to zoom this in for a very long time to start even seeing the activity on the x and the y on the y-axis, but still it means that it's available for use. Okay, so let me add that here as the final answer. The domain is all reals, okay, and then the range is all reals as well. Okay.